Please give me a thumbs up when it starts recording on your side. You should be able to see on your screen that we are recording. Give me a thumbs up if that's the case. Okay, great. So let's quickly jump into this question and not waste time. It is an easy question on complex numbers. Okay. And if you look at the question, specifically question 2, they are saying we need to find. So for question 2, they are saying we need to find the square root of 3 plus 2i. So in essence, what they're expecting us to do is to be able to take the square root. So what they are trying to make us to find is we'll take that square root of 3 plus 2i. They want us to find this in the form of a plus ib. So after taking the square root, we'll have some number a plus I times some number b. So if we may rephrase the question, essentially what we are trying to answer is what is a, which is the real part, and what is b, which is the imaginary part. So essentially we are trying to figure out what is a and also what is b. But before we start, I want to remind you that the a is a real number. So after taking the square root, we will have some form which is a plus ib. And remember that the b is also a real number. B is a real number, but it is the imaginary part. There's a difference. On its own, B is a real number, meaning it is some number which your sibling would know. It has no I, and then the same goes for I, just that the same goes for A. Sorry, just that A will be the real part, B will be the imaginary part, but both A and B are real numbers. Okay, so since we are trying to figure out what is A and B, well, what we can start by doing when we look at the expression above is to square both sides. So we'll square the right-hand side and also square the left-hand side. So let's quickly go ahead and do that. We have 3 plus 2i equals a plus ib. We know at the end, the complex number should take that form. But because we want to remove the square root, we'll square the left-hand side and the right-hand side. Okay. And when we square the left-hand side, you will see that the square root will fall such that we are left with 3 plus 2i. And then the right-hand side will simply be a plus ib. Because it is squared, it is 2 brackets. So we have a plus ib. And if you remember, this is just complex number multiplication. So we'll multiply that with that with that. So we'll do the typical FOIL. And we will do this with that. And lastly, this with that. Okay, so let's quickly do our multiplication. So we have 3 plus 2i equals, let's look at the green. So we have a times a, which becomes a squared. Then let's look at the pink arrow. Plus, we have a times ib, so which means we have I, ab. That is the pink. And then let's look at the blue line, or the blue arrow. You will see that we have ib times a. That simply becomes I, ab. Okay. And then when we look at the orange arrow, not sure if that is orange or gold, we have ib times ib. What I want to remind you is that I times I is -1. Okay. It's very important that you do not forget that, because when we do ib times ib, we'll have a negative, and then the b times b will give us b squared. And then now what we can see is that we can always collect the real parts. So a squared is the real part and b squared is the real part. And we can also collect the imaginary parts together so that AB is the imaginary part and that AB is also the imaginary part, which means that our 3 plus 2i will be a squared. Do we have a question? Okay, please make sure that we are muted unless you are asking a question, okay? Great. So if we collect the real parts, which are shaded in yellow or gold, we will have a squared minus b squared plus I. When we look at the imaginary parts, which are green, we'll have AB plus AB. That means we have 2AB. Okay. And then when we get here, this looks nice because when we look at the left-hand side, we can see that the real part is 3. And when we look at the right-hand side, we can see that the real part is a squared minus b. And we know when you have two complex numbers, the real part on the left-hand side must balance the real part on the right-hand side. The imaginary part on the left-hand side must equal the imaginary part on the right-hand side. So which means when we go to our imaginary part on the left-hand side, which is 2, it should be equal to the imaginary part of the right-hand side. Think of this as just balancing equation. Makes common sense. The imaginary part on the left-hand side should equal the one on the right-hand side. Same goes for the real part. So this means from what we have here, we can make two equations and solve for our A and B, and then we'll be done. How did we get to A and B? Well, we said when we take the square root of 3 plus 2i, we know it will take the form of a plus ib because we're taking the square root of a complex number, and we should get a complex number at the end. So let's go to the next page and start doing the work. So we will equate the real part, and we will do the same with the imaginary part. So equate the imaginary part. Okay, so when we equate the real part, it means we get 3 is equal to a squared minus b squared. And when we equate the imaginary part, it means we get 2 is equal to 2ab. And what I will do, I'll call these equations. So I'll call this one equation 1. I'll call this one equation 2. Okay. If you look at equation 1 and 2, we have two unknowns and we have two equations, which means we must now use simultaneous equations. Okay. That's the first thing which should come to our head. We must use simultaneous equations because we have two unknowns and we have two equations. So obviously what we need to do is simultaneous equations. Here we come. Simultaneous equations. So there's many ways we can go about solving for A and B here, but what I'm going to do is I'm going to take equation 2 and make A the subject. So we'll take equation 2, and on equation 2, if you look carefully, we have 2ab equals 2. So we'll first divide by 2, both sides, so that what we have is simply ab equals 1. Then what we will now do is make A the subject. And when we make A the subject, you will see that our A will simply be 1 over B. And this 1 over B, I will just call it equation 3. Now that I have A in terms of B, it means I can now go to the equation which we never touched, which was equation 1, and substitute A in terms of B so that the whole equation is in terms of B, and we can solve for B. And once you find B, you have found A, because A is 1 over B. So let's go ahead and substitute. So we'll substitute, I'll say we'll sub 3, equation 3 in 1. So if you look at equation 1 up there, which we never used, it is equal to 3. And then wherever we see A, we will put 1 over B, because our equation 2 ended up telling us that A is 1 over B. So we'll put a square and then minus our B squared. So let's deal with this equation. So we have 3 is equal to 1 over B squared minus B squared. So in order for me to just eliminate that B squared on the denominator, I'm going to multiply by B squared all over. Multiply by B squared. The reason why I'm doing so is because I want to remove that denominator. So if we multiply by B squared, on the left-hand side, you'll have 3. The B squared will come there. This one will cancel, be left with 1, and then we'll have B. B squared times B squared, it will be B to the 4. Okay. And then here, let's just transpose and write this in a form which looks better. So we will have B to the 4 plus 3B squared minus 1 equals 0. So now we need to stress about finding what B is here. And let's go to the next page with this equation and see what we will find. Do we have anyone who has a question so far? Okay, now I need to solve for B here, and I need to think carefully. How can I solve for B here? Well, what you should be able to realize is, even from high school, hope you remember the K method. So I know that B to the 4 is the same as that, plus 3B squared minus 1 equals 0. So I can see that this somehow, I can write it using the quadratic equation if I let my x to be B squared. Okay, some of you in high school, when you were doing such, I think it was famously called the K method, something like that. But instead of using K, I just chose X. It doesn't matter. So if we choose B squared to be X, you will see that our equation becomes X squared plus 3, B squared becomes X plus 3X minus 1 equals 0. And there we go. We are smart, and this looks like something which you can solve using the quadratic equation. So let's go ahead and use the quadratic equation. And if you remember, it is X is equal to negative B, which would be 3, plus or minus the square root of our B squared, which is 3 squared minus 4 times our A is 1, and our C is negative 1. And we should divide by 2 times our A, which is 1. So if you look at this, my answer becomes negative 3 plus or minus the square root of. When you look carefully, we will have 9 plus 4 there divided by 2. So which means our X is simply negative 3 plus or minus the square root of 13 divided by 2. However, because we are smart, we remember that, well, we didn't have any X here. So X is B squared. So I'll come back and say B squared is equal negative 3 plus or minus the square root of 13 divided by 2. So now I need to put in some focus on the plus and minus there. So we know that our equation always has a plus or minus, but then I need to choose, am I going with the plus or am I going with the minus? If I go with the minus, let's say if I go with the minus there, I will have -3 negative square root 13 over 2. And remember that this would be equal to your b squared, which means when you take your square root, you will take the square root of a negative number, which is -3 negative square root 13 over 2. And remember that we said b is a real number. So these negatives here, this negative and that negative, they will result in a negative number inside the square root as the whole, which means b becomes complex with the solution. So here we'll have a complex b. And this should not be the case. That should not be the case, meaning the solution which we will take is the one which has a plus there. So we'll take the solution with a plus. Okay, because inside the square root, we cannot have a negative, or the b squared should not be negative. B squared must be greater than 0, because when we take the square root, we want a real b. Anyone in the meeting who's not getting what I'm saying, please ask. So that means what we should have is b squared is -3 plus square root 13 divided by 2. And then we can now find our b by taking the square root, which will give us plus or minus -3 plus square root 13 divided by 2. Okay, good to go. Now we have our b, and we remember, or we recall, that on the previous page, we did some work and we found out that a is 1 over b. So since I have b now, I can easily find my a and wrap up my answer, which means my a is 1 over plus or minus. My a is 1 over b, so my b, as you can see, it is -3 plus square root of 13 divided by 2. So now I'm going to try and rationalize this a here. So let's try and rationalize the a. So if we do so, you will see that we'll have a is equal to 1 over. I hope you remember how to rationalize. I think we did it some time when we were doing grade plus square root 13. I think we were doing grade 10. So if I want to remove this denominator, which has these square roots, all what I need to do is to multiply by the square root of. I will change the sign of that number there, which will just be 3 plus square root of 13 divided by 2. And what you do on the numerator, you should do on the denominator. So this is just rationalizing 3 plus square root 13 over 2. Anyone who has a question? Someone has their mic not muted. Please check your mic. Someone is knocking also. So make sure that unless you are asking a question, you are muted. Okay. So our a will be the square root of 3 plus square root 13 divided by 2. When we look at the denominator, let's quickly multiply those. My plus or minus is still there. When I multiply 3 and 3, I get -9. And then when I multiply this 3 and that, I get plus 3 square root 13. And then now I go to the other one, square root 13 multiplied by 3. I will get -3 square root 13. And then lastly, square root 13 times square root 13, which will just give me 13. That's what I have. And all of this is divided by 2. So if you look at what happens, we have things which are canceling out. That term cancels that one. And let's look at the numerator, which is 3 plus square root 13 divided by 2. When we look at the denominator, we have 13 minus 9, which will give us 4. So divided by, sorry, something I missed here, very important. When we were multiplying here, this 2, when it multiplies that 2, it will become a 4, the denominator. Very important, becomes a 4. So when we do 13 minus 9, we find ourselves with a 4 over 4. So which means our A, essentially, is plus or minus the square root of 13, 3 plus square root 13 over 2. So there we go, good pupil. I now have my A and my B, and I should remember the solution I proposed. So let me copy it, and then we go to the final page. So this is what we had initially. We said when we take that square root, we'll end up having a complex number in the form of a plus ib. And on the previous page, we just found that a is plus or minus the square root of 3 plus square root 13 over 2. And we found that our b is plus or minus the square root of -3 plus square root 13 over 2. So therefore, our final answer, the square root of 3 plus 2i is the same as, I can pull out those, but let's put them in for now. So I have my a, which is plus or minus the square root of 3 plus square root 13 divided by 2, then plus or minus I, that is my b. I'm substituting back. My b is the square root of -3 plus square root of 13 over 2. So finally, I can just pull out the plus or minus, open the bracket, and simply have the square root, and then I can see I have a common factor of a half. So I can pull out the half here and just say I have 3 plus square root 13, and then plus I, square root of, I can see I have a common half, I can pull it out, and then say -3 plus square root 13. And then there you go. That is our answer to this question here of 3 plus 2i. So I saw that some of you use formulas which you found on Google. It will be a problem because in the exam you will not know these formulas. All what we are doing here is we are using general knowledge to be able to answer these questions. There is no need for you to use a formula in math, especially, which you do not know how you got there. Because remember, they mark the steps, not the final solution. The final solution can probably be 1 mark. So meaning if this question is 6 marks, you will only get 1 or 2 marks because you just gave them the final answer with not many steps to show your understanding. Do we have anyone who has a question? Anyone who has a question on this question? Any question from anyone? Where did I lose you? Or do we have someone else who has another question from that worksheet? Okay, let's pause this recording and see if we get